Hello and welcome to the Agricultural Engineering Podcast. This podcast covers all aspects of agricultural engineering. It is produced by the South African Institute of Agricultural Engineers. The series of episodes that will be brought to you has been funded by the Royal Academy of Engineering. We encourage you to tune in and explore the exciting world of agricultural engineering with us. My name is Tumiso Ngoepe and I'm your host for today's episode. With us today is Tumiso Ngoepe, who is a registered professional engineer with the Engineering Council of South Africa, specializing in agricultural engineering. She has 13 years of experience working at the Limpopo Department of Agriculture and Rural Development's Engineering Services Department. She has contributed to various projects, including the Ratlahane Table Grapes project and some aquaculture and hydroponics-based initiatives that are in Limpopo province. Originally, Tumiso is from Hamatlala in Frankfontein, and she spent most of her childhood in Mulechi, in Hamanamela, with her grandmother, Koko Pahledi, who is now 97 years old. Today, she joins us to discuss the critical role that agricultural engineers play in aquaculture and hydroponics. Tumiso, it's a pleasure to have you on the Agricultural Engineering Podcast. Welcome.
Thank you so much, Kutazo, for having me.
Thank you again for joining us. Let's dive right into the conversation. So please share with us about your journey of becoming an agricultural engineer.
When I was growing up, I always witnessed my grand, like the interest thing, who was a farmer working very hard to feed us in the farms. And then I later attended my high school in Seher Oppenheim High School, which is a boarding school around Hamatlala, where I further loved the agricultural sector. And then also just to add, at home, my mom, even currently, whom was a teacher then, she was part-time doing poultry farming. So I would say farming and agriculture has always been in the background from where I'm coming from. So just to add on, while I was at high school at Oppenheimer, I was offered an opportunity to attend the NAMPO Expo. And that's where I got to understand and I learned more about agricultural engineering, and then I loved it from then. And then I pursued it straight away. And which also I would like to appreciate. I received a bursary from Department of Agriculture, which took me to UKZN, University of KwaZulu-Natal, and that's where I studied my Bachelor of Science in Agricultural Engineering. And my love for water, it drew my attention to water-related projects such as irrigation, aquaculture, as well as hydroponics.
I'm particularly interested in the aquaculture and hydroponics projects that you've been involved in. So before we can dive into that, I just want to understand, I think our audiences will be curious, what is aquaculture and hydroponics and what's their difference?
I would like to explain it from the simple point of view. When you speak of hydroponics is like, you know that on a conventional farming, you plant your crop in the soil, and that's where it gets its nutrients, and then you irrigate, that's where it gets its water and everything. But with hydroponics, you don't have the soil as a substrate. You actually plant your crops in a nutrient-rich water, and then you control the amount of nutrients you need into the crop from that point of view. So basically, you don't need the soil or the land to plant in a hydroponic. You just need a system that you can establish anywhere that you can be able to control, and then you do your produces. And then as far as aquaculture is concerned, you'll understand that this is where you rear fish. You breed fish, and then it can start as far as like it starts from a hatchery, there where you hatch your eggs, and then you do your fingerlings, and then from there you take that into a breeding ponds, and then after breeding it for a few weeks, then you take it to a production ponds. So literally is a way of you artificially breeding fish at a larger scale so that we can have fish, which is also a health benefit to the population, moreover to the growing population of South Africa. So you artificially have systems that are put in place, which are done by agricultural engineers that will be able to produce the fish until it goes to the market.
So whilst we're still talking about production, right, I want to understand with regard to hydroponics system, how much can one get in terms of product yield per hectare of a hydroponics system?
So when it comes to hydroponics, you have a system where you grow your plants vertically, like you grow your plants not on a conventional system, you grow your plants on the ground, which is horizontally. But with hydroponics, you can grow them vertically, which means you have more population of plants per hectare or per area. So it means, for example, if you grow vertically and then the system, it can allow you to grow even up to, you can do 25 to 28 times what you can do per hectare of conventional farming. So which speaks to really the numbers that you're speaking about, to say it can go exponentially like that too. And also it grows fast. When you're growing in hydroponics, the growth rate is not as compared to the conventional one. And then there's many other benefits as well that just says why hydroponics is the way to go. So this will help us with this high population that we're experiencing around the world, and it will help us to grow plants quicker. And when you're doing a nutrient-rich water, so it allows you to directly inject what nutrients you want, particular quantities that you want, directly into the plant, when compared to conventional farming, where the plant actually has to have like deep roots and then they fetch the nutrients by themselves. So those are some of the benefits when you are dealing with hydroponics, which are very outstanding, if I would say so.
So you've mentioned that you've worked in quite a few projects that are water-based, right? So let's go into a little bit of depth of some of your projects that you've worked on. Can you please take us through maybe one project that you are particularly proud of?
When it comes to aquaculture, the one that I've worked on, I worked for the Ntompi Seleka aquaculture ponds, where we are upgrading the current system. And also when we were upgrading it, the system was old and it was very bushy, so they wanted to upgrade it so that we can now start to produce fish. So it was done in processes. We have done a hatchery, and then after we have done the aquaculture ponds with other projects. But the one I worked on, it was there for the Ntompi Seleka. And then after doing the aquaculture ponds, we also recently just handed over the fish processing unit, where after producing it, we have to take it to the processing unit so that it can go to the market fresh as possible. So what we have done is to produce fish. What we wanted is to produce fish at a large scale. And maybe, Kutaza, I want to highlight to say, when you're doing aquaculture, you can either do it in a closed environment or you can do it on an open environment. The one for Ntompi Seleka, it was an open system where there were ponds that were on the outside, like they are like dams, like they're like earth dams, but they are outside. But then there are also systems that you can do in your garage or wherever that you are at, which is in a closed environment, which is the good part of it, to say you can do it wherever you are. You don't need to actually be having big land to practice these practices. So when we are producing fish at large scale, you need to have a design and the construction of the whole system. So that's where we tapped in as the agricultural engineer, so that we can properly design the systems. And then what are the other important things that one needs to look into is to look into the site location of the ponds. So in my case, because I was doing it outside, it was important to look into the slopes, also look into the natural slopes, which makes it advantageous for your proper drainage And also you want to capitalize on your gravity inflow of water into the ponds so that you don't spend much money on pumping water. So this helps because in aquaculture, you need water that is regularly moving so that it can keep the water fresh inside the ponds. So if you're not having a system that is gravity fed, so you'll forever have to pump water through the ponds, which is going to be very costly for you. So it's important to get your slopes right. And also you need to look into your depth consideration depending on the weather conditions where you are at. So that you can have, when you're designing your production ponds and breeding ponds, you need to be very careful of your depth considerations, which for production ponds is between 1.2 to 1.8 meters, so that your fish can hibernate when it's very hot and then things like that. And then also system flow of the ponds, it's very important. So remember, you are rearing your fish. You are taking it from the hatchery, and then after it becomes fingerlings, they have to take it to the breeding pond, and then from breeding pond to production pond. So it's important that your transportation, all these things, they are not very far from each other. So they are strategically placed such that you don't have high mortality or the high loss in your production. So imagine if you're taking your fingerlings long distance and then you have high mortality. It means by the time you take from breeding to your production, and from production to your hatchery, to your fish processing unit, you will have a low production that you'll have taken there. So it's important to have them strategically placed. We would like to have them very close to each other to avoid such losses. And also we need to look into the capacity that we looked into. For me, we were having 8 dams, and that we had to rehabilitate. And then what I did is to say the previous system, it was isn't that the water is draining each time, and then it was draining the water back into the river, which I saw it as a environmentally unfriendly way of dealing with it. So what I have incorporated is to integrate aquaculture with irrigation for the Ntompi Seleka, such that we use the last dam as an irrigation dam. This is so we drained all the water from the pond to the irrigation dam so that they can irrigate the plants with the water from the aquaculture pond. And which is also very advantageous in terms of irrigation, because the water from this aquaculture pond, they are nutrient rich. So which means we use less fertilizers in the irrigation field. So this one, we just converted it by compacting it nicely, constructing it, and then also line it, and then connect it to the existing pump that was already available to pump into the irrigation system. And then they use that water interchangeably with the fresh water they were using from the canal. Also, the other importance is to look into the proper management and maintenance of the system once the project is completed. Because with us, we will design, and then after we come and supervise, the contractor who will be doing the project to make sure that what they are constructing is as per the specification we have highlighted or we have shown on the bill of quantities and specifications. But the other shortfall I've realized with our farmers is also to look into, can the farmer or the end user use the system efficiently and effectively? So it's important to look into enriching these end users with the knowledge, the know-how of how to use the system and also how to maintain it. So it's important to take them to short courses so that they can understand these processes fluently, so that when they start producing, they don't get to have a lot of problems. So, for example, like when you're dealing with hydroponics, you have to have, like, your management needs to be very intense in such a way that you need to know what you do, what you inject, when to inject, what pump to start, when to start it, things like that, so that your system can be flowing nicely. And if you're having problems like your filters are not working properly, those things are the things that they need to know, where to touch, what to take out, and how to clean their filters and things like that. So those are very important trainings that are necessary for the end users, which need not be overlooked, so that the overall system can be efficient to them and not frustrating the end user.
So we can conclude now that the benefits of both aquaponics and hydroponics farming systems is for fast production and increased product yield for either the fish or any plant that one would want to have in their farm. My curiosity lies with the integration of hydroponics and aquaculture, which is what I believe is called aquaponics. Do you also have maybe projects that are integrating these two systems?
On this one, I was not interacting with the hydroponic, but it was a greenhouse which could one could turn it into a hydroponic. So with what I'm trying to say is that they can talk to each other very nicely, in a sense that the crop need nutrients, and then the water that you discharge from the aquaculture ponds, they actually are nutrient rich. So it means that you also need to test the water so that understand the type of nutrients that you have in that water, so that you know how much more you need to meet your requirements for whatever crop that you'll be having, which differs from crop to crop, which is another good thing to say. When you're doing hydroponic, you can manage your nutrient injection very carefully so that you can meet the requirements for your particular crop. So that's why I'm saying, for me, I'm seeing it as the future of where we need to go, especially with the global warming that we're having and a lot of issues that we are experiencing when we're dealing with conventional farming. And another thing that we not need to shy away from is to say, when we are dealing with most of our farmers, they are struggling to acquire water use licensing because the water is very scarce, so they're fighting for the resources. So this will help them in a sense that when you're doing hydroponics, most of your water is recycled. So you do not need much water per area. And also remember, what you're doing is you're recycling the water and also you're growing vertically. So it will help farmers to plant more with the less water authorization that they have received. So for me, it's got a great benefit in that. And also it means more farmers can plant with the less resources that we're having.
I think you've highlighted the benefits of aquaculture and hydroponics quite well. And now I'm thinking about the status quo in South Africa, where conventional farming systems are used to produce food. What significant role do you think aquaculture and hydroponics will play in our current food systems?
Okay, the significance of aquaculture is to optimize the production of food in this high population country within limitations like global warming. So, for example, when we're dealing with a hydroponic, one can opt to a vertical farming in hydroponic, which maximizes the use of space or land vis-a-vis when you're doing production in a conventional setup. And also you've got a shortened growing period, which is very evident in hydroponics. That's you need more food can be produced at a given time. So you can, like how it shortens, you can even be up to half the time you need. Let's say you're growing lettuce, it can grow at half the time you need to grow it in a conventional setup, which means you can grow 2 times more, plus the population that you have per area. So it means you're exponentially growing your more food at a given time. And also, like I mentioned, the use of less water that is you have when you're comparing to traditional farming. And then with it differs from system to system. So you can use to 10 to 20% water as compared to the water that you are using in a conventional farming, which means you can have more production with the less water that you are having. So which for me is a good thing because it saves us water in this water scarce country. And then farmers also, like I'm saying, they're struggling with the acquiring of water use licenses. So it means when they get authorizations, they can be able to use water authorizations to plant more with that water. And also it produces higher yields in a sense that you are injecting the nutrients that is needed to the plant directly. So you are giving the plant what it needs, exactly what it needs. So your produce is having high nutrients, which is also meaning we're having good quality products that were coming out of the systems. And also there's a shortened supply chain that you have as an advantage, in a sense that normally you have big farms that are in the rural area. So when you're dealing with hydroponics, you can even set up a system even in the urban areas. So you don't have to have big trucks collecting this produce from the rurals to your urban areas. So you have your produce there when you need it, and then it also becoming environmentally friendly, because these big trucks, when they are transporting this produce, they are emitting their carbons, which is not good to our ozone layer. So for me, there are many benefits that we can actually put into place to emphasize, to say the way to go, this is the way to go, and we need to shift to this new methods. But with people, we are reluctant to do certain things. So people might not want to shift, especially old people. So it's important for younger generation to tap into this and then also explore it.
Yeah, I agree completely. So considering that our main source of protein is poultry in South Africa, right, with the fish that is being produced from aquaculture, is there a market for it or promotion for consumers to buy?
Okay, as far as benefits of having fish is a healthy meat. So look at it as white meat. So you understand there's some people who are restricted from eating red meat, and because of it's giving them diseases. So then they are now being channeled to say they can eat fish, and then those are the healthy way of living. So for me, it's a healthy way of living because it's high in omega-3, which is important for your growth. So if you're having kids who eat fish, a lot of fish, they tend to be more smarter when they grow up. So for me, I'm saying we need to invest more into this, and then actually keep it in our daily diet. So I think previously it's because maybe it was regarded as an expensive item. So if it's done in a large scale and then it's readily available, people will be able to buy it, and then they can incorporate it into their daily meals, and then it will be easy for them. So also accessibility to that it's very important. So you understand, most people, when they're speaking fish, they're speaking tinned fish, which is not fresh fish. So we need to look into systems that can get us more fresh fish at a more affordable prices, so that even the people from the disadvantaged background, they can be able to afford such produce and then incorporate it nicely into their daily meals, and then that will also assist them in these benefits that we're mentioning.
So for the Ntompi Seleka project, which fish breed were you designing for?
They are mainly doing tilapia, and they're doing also catfish. So catfish, it's what most people they like, and then some people, due to religious reasons, they do not eat catfish because it's a carnivore. So tilapia is the choice that one could opt to.
You mentioned that there's quite a lot of improvements that are needed in the systems, right? One of them being in the area of maintenance. What are your perspectives on the role of agricultural engineers in improving hydroponics and aquaculture systems?
As far as the role that we as agricultural engineers has to play in this, improving the sustainability of this farming system, and also moreover introducing it to some of the farmers, I would say. So I was giving an example to say, let's say we have an applicant who's requiring funding to do a 10-hectare irrigation system. So one would do in the planning report, because what you have to do, you can't just give it to the farmer. You actually need to present it to them. So in my planning report, what I would do is to try to highlight the importance of incorporating the hydroponic into the system. And also I would say, let's incorporate it at a small scale in such a way that they can get to understand it from a small scale point of view and get the feel of it before they can now take it to a bigger scale. So instead of doing perhaps 10 hectares, I would do 9 or 9.5 hectares. And then on a half a hectare, then I would now incorporate the hydroponic system, which will now be like a trial for them. So in this case, if a farmer is doing hydroponics, for example, They could do it even in their garage, like a single garage or a double garage. You can practice it from there and you can get good yields. You can be able to take it to the market. So small scale, really, it means you can start with what you have, because even the things that you may use to do the hydroponic is some of the reusable materials that you can take it from there. But there is also a high level of designing that we can incorporate into the system depending on your capital that you are having to do the system. So one would even do it at around 20,000. If they're having 20,000, they can be able to establish a proper small scale hydroponics that they can be able to plant their crops at a small scale and then also take it to the local markets that are around them. So as far as the aquaculture, one would you would need a number of I would say containers. In this case, you can use things like JoJo tanks to as your containers, but you can ask for the ones that are open based, like there's special ones for that. So let's say you're using a 5,000 liter and then also maybe 2,500 liters as breeding pond. So you need roughly, let's say, 3 of those tanks, and then which is around less than 10,000 to get all the tanks and everything. So, and the pumps as well, because you need to inject the oxygen into the water and things like that. So one would start an aquaculture system, a small scale one, at around 50,000. Also counting also to say you need to buy those fingerlings, you need to buy the feed, you need to buy some nets and handling equipment that you need to use in that small scale. So from there, from small scale, one would grow into a bigger scale once they understand what they're doing. And also once they understand the benefit they're getting from the production that they are having. So I would say those are figures that are out of my head that they can be able to use. But it also differs from if you're going to procure this. Personally, you can go and buy those things yourself without a middleman. It becomes cheaper as compared to when you are doing it through a contractor who will need a profit for whatever that they are doing for you. So, and at a small scale, I really would not encourage anyone to look for a contractor, because you can do most of the things yourself. And then as the department is available for all the farmers who are around us to assist them at no extra cost. All you need to do is to go knock at their doors and also ask them. And then if you have the funding for yourself, we will come and help with the expertise. So as far as us, you need to do as agricultural engineers, you need to do proper diligence into the designing, making sure that when you do a preliminary investigation, you're covering everything. So as far as the preliminary investigation, you need to check the water sources that you are available, the energy sources, and also consider the alternative energy sources that you can use, because we are using pumps. And then some farmers, electricity is a high cost in any production. And also with this load shedding, it's also not reliable. So you need to look into alternative sources like solar and other things to can be able to use into your system. And also when you're designing, you need to do it that thoroughly and also be very specific, be detailed in your specification, so that it can be easier when you're doing your monitoring of the system when they are constructing it, so that it can be easy to monitor, and also for the contractor to understand what you're trying to say in terms of the drawings and everything. And also the monitoring, like I was saying, monitoring and management. After that, all is done, it needs to be properly done and to advise the farmer or the end user on how to do that.
I like that you are giving practical advice that someone who might want to start their own system can use. Now, you mentioned that there's high maintenance issues, which includes testing water throughout the production cycle, right? What I want to know is with regard to technologies that are involved in these farming systems. With technologies that are being used in this farming system, how has it been evolving throughout the years?
Overall, these systems, they actually allow the farmers or the end users to grow plant anywhere and throughout the year. So you're no longer having seasons where you say you can only plant this crop once a year, because you can now maneuver, or we can work around the climatic conditions and change them to suit the plant you're growing. So you can actually have longer growing periods throughout the year, which is an advantage that you also have when you're using systems like hydroponics. So it's having such green lights to say we have more reasons to do it than not doing it. And also we're looking into most supermarkets or the shops. They have such requirements, like when you're going to shops like Woolworths. If you want to supply shops like Woolworths, you actually need to have a hydroponic or a greenhouse to can be able to meet their standards, to can be able to tap into that market. So it's important if you're also looking into, increasing your profitability as a farmer. So for me, is to say, this is one thing that we cannot ignore, especially if now the market is looking for that from our farmers. So our role, we need to give the farmers the right tools so that they can be able to use them, and also assist them in other processes that they may not understand. Like I'm saying, like the water, you need to test the water just to understand if it has any nutrients or is contamination. The class of the water is important to understand what class it is and what are the substances that are making it that class. For example, if you have high nitrate water, if we have salts in the water, are they the right salts and things like that, so that you can be able to advise the farmer accordingly. And also the pH of the water is important because it needs to be at a certain level between 5 to 6. So if it's not, it can also be altered. There are off the shelf things that you can buy to incorporate into your water to make sure that your pH is balanced. So I'm saying the technology is there, and then it's also improving itself. So we need to move swiftly with it and then be up to scratch and up to date. So as agricultural engineers, it's also our big goal to say we need to be updated into the new technologies. We need to know what is happening out there around the world so that we can be up to date. We can't keep importing our produce when we have the opportunity to actually grow our plants throughout the year. So it's an opportunity for farmers to tap into and take advantage of the technology.
How are you ensuring adoption of new technologies such as control systems as the department, considering that most of your project beneficiaries are old people?
I would say currently maybe they are not as capable because we have not maybe done the introduction that deeply, because we need to actually, before we can even start to sell the idea, we need to take them to workshops. We need to, inform them of this current, and then actually need to visit farms that are actually practicing such, so that they can see it live, and then they can see, when they see the figures live, then they can be more convinced than when you're just being told that you can do this, and then you'll get 20 times what you are getting, which they may not understand, and it will not make sense to them. So it's important to get them a direct feel to say, this is what is there, and then take them to those discussions so that they can see. And then from there, we can advise them better from a point of knowledge to say, okay, now that we have seen, what is your take? And then this is what we think we can incorporate in this whole thing. Because any farming, if you think of it, Kutazo, it's still demanding, whether conventional or otherwise. Farming is demanding. I've never seen a farmer who has to wake up at their own time. They wake up at dawn, they go like early morning, they go to sleep late at night. So any farming is demanding. What we're just saying to say, you can have this a bit more smarter farming system, which can be also computerized to say you don't need to be there all the time. So if you incorporate some computerization into it, you can actually do it at much lesser time than you were doing the other one. So which is a good advantage, because I would say in this whole system, the buzzword could be with less, we can do more, because you use less water, you use less land, you use less fertilizer or nutrients, you use less mechanization as compared to conventional. And then it means you use less production costs, which is way much different to the conventional setup. So for me, there is more to this, and then we actually need to move into it. So as the department or as the agricultural engineer, our role is to advise the farmers accordingly, and then so that they can tap into this. And I also see more of our young farmers that are coming forth to join the farming industry. So which is going to be a bit easier to teach such farmers as compared to the old ones. And then also these young farmers, some of them, they've done agricultural related courses, which is now even an advantage, because if you have a crop scientist who's now becoming a farmer, you can understand, they even understand crop more than we do. So it's much easier for them. When you're giving them numbers, you're giving them figures, they grab easily. And for them to convert is not going to be a problem. And then we'll be moving at a swifter and faster rate.
You mentioned that there is a need to keep up with the latest technology, right? So how are you doing it, keeping up with the latest industry developments, specifically in aquaculture and hydroponics?
How we stay up to date is its various means, really. We need to attend different courses that are having these new technologies. And then there are also conferences that are there with the year we have got annual conferences, South African Institute of Agricultural Engineers. And then there's also monthly branch meetings that we do attend from there. So that's where we can incorporate the service providers that are having this in their market. And also you can incorporate farmers who are actually practicing such new technologies to come and tell us from the farmer point of view, what are they doing? What should be done to can be able to meet the growing rate demand of food requirement. And also you need to attend some workshops that are also offered by different service providers. You also need to be able to research on new technologies and ways to improve existing infrastructures, because you need to be up to date. And then also you need to have some visits to some expos and visit other farms so that you can see what other farmers are doing differently to you, and then so that you can also try to incorporate what they are doing, or maybe do it a bit different from them, but then you get some ideas on what different farmers are doing, and then you take it from there.
Let's talk about the challenges from your experience, Tumiso. It can be challenges that you've seen farmers face, or you as an agricultural engineer face, in designing these farming systems or doing the technical detailing. And also take me through how you have overcome the challenges that you have experienced.
Let me start with maybe hydroponics from your question to say there are many other challenges. As much as we are having these good things we have to say about it, there's also like the drawbacks that we can mention. Just to mention maybe the most difficult one, I'll say, is the high cost setup that it's related to hydroponic. Especially if you want to do atomization and things like that, you understand you have to buy all those pumps, all those atomizing items. So how we can counteract that? Because as a farmer, you're going to tell them to say, if they are to do their 1 hectare as compared to doing your hydroponic, when they see the cost of hydroponic is 2 times or 2.5 times what they need, they will stick to what they know because it's much cheaper. But then we can assist them into looking into different fundings that are available to can assist them, and so that it can become a bit more lighter for them to achieve. Which different departments, not only Department of Agriculture, like different departments do offer different assistance. Some departments or some institutions, they offer like a portion of the funding. Let's say you need 500,000, they can offer you 60% or 70%. And you come with a 30%. And some they offer that as a loan base, some they offer that as a grant. So it's different from department or institution. That will counteract the high costs that comes with the setup of such systems. And also there's also high maintenance and high monitoring. So it's important to capacitate the end users, like I was saying, to make sure that they know what they are doing so that they can also have confidence in the system. And not, when you're not confident about something, you may not be able to take decisive action of what to do when you see the crop acting like this and things like that. So they need to be taken into continuous courses, not only once. You can't learn everything in one day, but they need to be continuously be updated, maybe quarterly or in 6 months taken to courses so that they can understand the system better, what are the challenges, and then how to overcome these problems and things like that. And then running the system again itself, like I'm saying, there's high technology that is there. So it's important to have someone of a know-how of dealing with pumps and things like that who's nearby, because if you have your pump breaking down, you don't need to wait for long until you fix it. So also there are other crop-related issues like root rot that you can have as a waterborne disease. So you need to be able to know what to do or what to use to counteract that, and also how to isolate such problems. If you have a crop that is having a problem, you need to isolate it, or the water from such a system needs to not be recirculated to the reservoir, because what's going to happen is going to affect all the other plants, and then you can have a great loss from there. So as far as aquaculture, in an open system, it's having its own challenges, but then the challenges are maybe a bit lesser when you're coming to your closed system. For example, open systems, you still need to deal with bait control, because you need to, some baits, they love fish, so they'll come and predate on your fish. So you need to be able to control that. So there are other systems that you can use. Some farmers, they use nets, but it depends on how big is your pond. And then if a pond is big, a net might not be feasible enough. So you can use things like bait repellers that you can use to chase away the bait. And then there's also a risk of high mortality. So if you're not properly managing your system, like if your ponds are far from each other, or you're not giving your fish the right food and the right nutrients that it needs, they may die. Or if the population is not as per the requirement, you may overpopulate your pond, and then they may have high mortality, or they can grow small, like they don't grow as they are supposed to be growing. So it might be a problem when you take such fish to the market. So you need to control your population or density, stocking density. And also knowing the quality of water you're taking into the system is very important, so that it does not affect your produce. And oxygenation, like I'm saying, this is using pumps to put oxygen into the systems. So you need to guard against things like load shedding. So you need alternative systems to put in place, because you need this oxygenation going on and on throughout. So if you don't have a pump running, it needs to have an alternative system that can kick in to keep the pump running. So those are some of the, I would say, unique challenges that it's having, because it's not a forgiving system. It's not that forgiving. So you need to have everything in place at a particular time, all the time. But otherwise, if you have everything in order, your results are more evident and promising.
I am glad that you emphasized on the opportunities that exist to access funding from various departments and institutions in South Africa, because I believe it will be very valuable information for those who are listening, and some people who want to venture into these farming systems, right? So, Tumiso, can you share some of the lessons you've learned throughout your career that you think would be valuable for others who want to pursue a career in agricultural engineering, or those who want to start farming using aquaculture or hydroponics systems or aquaponics?
First and foremost, if you want to do any farming, like I said, Kotazo, you need high level of patience. You need to love what you're doing, because you need to invest your time in that. So if you're not going to be patient and, be willing to learn, because like there's new technologies, if you're not going to be willing to learn its time into what you are doing, you will not get what you're supposed to be getting. So you need to also have good people skills. Like as an agricultural engineer, you deal with people of different types all the time. You need to have good people skills. You need to be able to remain calm even when someone is shouting at you, or, be able to understand people from different perspectives, because as people, we are different. You'll find a farmer who does not understand, or who's very talkative. And then you need to be able to listen to that farmer and then be able to respond to the person accordingly. And then there's one who is, we have different characters of people. So people skills is very essential. And I would say what I've learned also is to say, as an agricultural engineer, I would call us a jack of all trades because we do almost everything. But it's important to know your niche and stick to what you know, which is a best practice. Because as much as we do everything, we get to be requested to, one can do type into building, we do peg houses, we do this poultry houses, piggeries, we can tap into irrigation, we're dealing with water reticulation and things like that, dam designs, and there's a lot that we are doing. But then there are areas that you need to be very careful to enter deeply into. Like if you're going to do deep electrical, it's also important to tap and request a specialist for that, and then don't shy away from asking for specialists to assist you. Like when you're doing aquaculture at Ntompi Seleka, there's a time where we requested an aquaculture specialist to come and advise us as far as the layout that you have done, to say, is this feasible? What are things that they think needs to be added to our designs? So it's important to not try to be an island in doing this. And also, it's important to be very detailed, especially in your specifications and in your reporting. Because when you are dealing with a contractor, contractors can be very tricky people to deal with. So you need to be specific, and your specification needs to talk to them, and then it needs to back you up what you are trying to say they need to do. And also, you need to be someone who can do proper market research, and then also incorporate the business plan that they have done into your design, because this is what the end user is trying to achieve. So you don't have to just try to sell your idea without meeting what they need into play, because we have a lot of people who would abandon the system, these nice systems that you have done, especially if they feel they are not being heard. So it's important to incorporate, like as much as you want to do technology, you need to listen to the farmer and also get to understand the willingness of the farmer to have such technologies incorporated in their system. And if they are willing, we can incorporate it. But if they are not, perhaps it's best to do what they are requesting from you, so that you don't have a wild elephant there. You do a nice thing, at the end they don't use it, and then they do their own thing.
You've just emphasized on what most of our guests have mentioned, the fact that agricultural engineers work in multidisciplinary environments. And I think you really gave a good example of it, that you had to work with an aquaculture specialist. And most people do mention in our podcast that really, to be an agricultural engineer, you have to adapt in environments where you work with people from different disciplines. Now, I know that some of our listeners would want to reach you, Tumiso, and maybe someone would want to find out, where do I get the funding opportunities that you've mentioned? How can they reach you?
Okay, my first point of contact, we have the department cell phones that they provided for us. They can get hold of us during office hours. And then my number is 066 079 3405. So, and the landline, but I'm really in the office. I think I'm in the office 20-40% of the time, but my landline is 015 294 3429. And also, they can also send me an email to Ngoepe, NGOEPE, for Tumiso, at agric.limpopo.gov.za. So that's where they can send me an email, and then I will respond to them with anything that they need, technical issues to say. Because the challenge that you have sometimes, Kutazo, is to say, when you say you are an agricultural engineer, people be as coming with crop scientist problems, and then I will refer them to the relevant people, because in agriculture we have got a vast careers or people who are there to assist in different sections. Like we've got the crop scientist, we have a soil scientist, we have all that. So there are people who can assist you in that. So as far as funding, I would say it's important to know your location. For example, the structure that we have in Department of Agriculture in Limpopo, we are having 5 districts, which is Mopani, Vembe, and we're having Capricorn, we're having Sikukune, and we're having Waterberg. So you need to first understand where do you fall under this district, and then you can now locate your nearest district from there. But besides reaching out to districts, from district level, we have got municipalities inside the district. So, for example, in Sikukune, there is a Marble Hall, there is a Ephraim Mohali based in Marble Hall. There is Elias Motswededi based in Foresdal. So that's where you can close by reach to the department. There's also service centers going down that are based at the villages, like it's spread across. But then to get the funding, there's an applications that are open almost every year. There's cycles that they open the applications. Somewhere between June and August, that's roughly where they have the publication, which is done on public platforms. But then applications are open to everyone, especially if you are a farmer. We want to fund farmers, not fund someone who just sitting at home and being bored and thinking, let me just go get a funding. So we are aiming the funding to farmers to assist them better their systems so that they can achieve their results better. So there is also a screening process that will screen farmers away from those who are not farmers. That's what I'm saying. We want farmers. We want proofs to show that you are a farmer, so that you can show us to say you've been farming in this, and then these are the proof. So the forms are different from type to type. If you are subsistence, or you are small scale, or you are doing it at a more conventional scale. So there's different types that you can apply for, and then there's also laws for different ones. So I cannot tap into that now. But then when you come, we'll understand your problem, and then also direct you to the right form that you need to fill and the supporting documents that you need to attach to your form. And then you will take it from there. Also is to understand to say agriculture has a lot of applicants. So we can't help everyone at the same time. There will be a waiting period. That's why I'm saying there are other institutions that also offer funding, especially to young women who are doing farming. There's plenty of other institutions that do offer funding. So you can also tap into such to cannot be in the waiting list for agriculture, all of you, and then can get the funding. And if you need the technical expertise, you can also come to the department, ask for that, to say, I have the money to assist myself, but I need to understand the technicalities that do not have the know-how. That's where they will engage us as engineers for the department to come and assist you, which is also to say there's a lot of you, but then we'll come and assist you at the most convenient time.
Thank you so much, Tumiso, for not only speaking about the role that agricultural engineers play in the aquaculture and hydroponics area or field. You also mentioned the role of farmers, and I appreciate that. Any last thoughts before we can end the episode?
Okay, thank you also for having me, Kutazo. This was very interesting to do. And I just want to say, as far as the farmers or even the youth, encouraging the young ladies who are out there. You know, sometimes you find someone who went to school, university, they're educated, but they don't have a job. So it's important to think outside the box and not just think of what you have done. You know, if you have done business activity, for example, you can incorporate that into farming because it is there. All we just need to know is to understand the crop side of things and how it's done. And then you're already a business person because you have business admin degree or diploma. Then you can take it from there and you can make it, you have a higher chance of making it than someone who maybe does not have any background of anything. So what I'm saying is to say to young people out there is to, you know, think outside the box. They need to look into different perspectives. And then I always tell people to say, we have access to internet, but we don't use it the right way. we use it to just go to social media and laugh and things like that. Those people we are laughing at, they're actually making money. So I would say, not to say bashing social media, it's a good way of entertaining us, but you can't be entertained the whole day. If you don't have a job, look into other opportunities, search, go to YouTube, look into what you can do differently and skills that you can gain. And you can also learn about a lot of this aquaculture or hydroponics from online, and then you can also get to search the different fundings that are available, where to start, even on a small scale point of view, like we spoke about. You can start from there and then you'll grow from there. You can end up having a very big hydroponic farm which supplies a lot of woolworth by, I don't know when, but in the near future. And then that will be like, you make a lot of money, and that will make you one of the richest people in this country. So for me, I'm saying let's use the resources that we're having, direct them or redirect them to different uses, and then also tap into other industries, knock into doors. Don't be afraid to knock at doors. The worst they can say is no, and you can go to the next door and knock, and then you never know when the yes it will come.
Thank you very much, Tumiso, for joining us. We really appreciate your time. Well, and that was it from Miss Tumiso Ngoepe, who gave us a deep dive into the hydroponics and aquaculture systems. Thank you for tuning in and listening to the Agricultural Engineering Podcast. We appreciate your support. Don't forget to like, rate us, and comment. Share this podcast with your friends, family, and colleagues. You can find more information in the description box, and we look forward to connecting with you in the next episode. It's goodbye for now.